Okay, in these examples, we are going to find some of the measurements. So the first one, we are going to find we have three data sets here. We have data analysts' salaries, we have data analysts' salaries, and we have number of people. Yeah, we're going to talk about this when we come to it. But now we will be finding the measures of center, the measures of center. The measures of center, that means we are talking about mean, median, and mode, basically, right? So to find the mean here, we're gonna say, okay, mean, let me just introduce, okay, have another. So this is my mean, this is my median, this is my mode, okay? Well, basically, let me go there, okay, here. Let's keep it there. Mode, I'm gonna take the last one. So the mean is we're using, first of all, to use Excel, we're gonna do first, let me do this, formula text. Okay, to find the mean first, we're going to do equal. Every time you use Excel, use a function, you have to start doing equal. So the function says average. Average tells you the mean. After you type average, open parentheses, then you're going to select your data. Select your data, close the parentheses, enter. So the average. This is the average. Here, actually, I'm showing you the formula that I used only. Okay. So this is the mean. So let me use this. To find the median, we get equals median. Same thing. Select your data, enter. So this is your median, right? The second data set, we're going to do the same thing. Average. Then we're going to do the mean, the median. If you find the mean and the median for both data sets, first of all, I have the same data set except for there's one difference, actually. If you look at the median, you have the same median, but the problem, you have different mean. How do we find the median for this data set? We organize the data. We have to organize the data in order. Okay. If you organize your data in order, for example, you do right-click and sort, smallest to largest. Let me sort this one, smallest to largest as well. If you find the median is going to be the middle value, which is 155. The middle value is 155. The mean, how do you find the mean? We add all of these values, we divide them by 2, 4, 6, 7. The mean here is different because we have a different value, which is the 1 million here. It was $316,000. Now it's a 1 million. What does this tell you? It tells you that the mean is sensitive to extreme values because this is an extreme value. Because the data analyst salaries between about 100,000 or 98,000 to 2004, but there's one extreme value. One person takes 1 million, which is, I don't know, which is my mistake or no, but it shows you that the average is different. It's 268,000. So the average for two sets is different, and there's a big deal of difference because, and the true value is that one, basically, is not this one. Someone's going to tell me, oh, because we have 1 million, that's correct, but this, I mean, this is not accurate. This doesn't give you really the average value of that list. So the mean was affected by the large value, the extreme value. Either it's going to be large or small, too small, which is the extreme values or outliers. The mean will be affected because you're going to add all of the data. All of the data are incorporated in the calculations. So that's why it's impacted by the extreme values. That's why the mean here is not helpful to use the mean. That's why we use the median. So the median is the winner here because the median is not impacted by the extreme value. But the mean hasn't, I mean, the extreme value has an impact on mean. That's why the mean is not a good measure in this data set. The mean is a good measure here because it's not, it doesn't have any, I mean, we don't have extreme values here, and it tells you really the good values of the average is 170. That makes sense. For me, it makes sense more than the 155. So what did we learn from here? Extreme values. If you have extreme values, we use the median. If you don't have extreme values, we use the mean. The other question, or the last one, it says what? We have a number of people now. The question says, actually, the owners of Smoky Mountain Pizza are planning to expand their restaurant to include an open-air patio. Before finalizing the design, the managers want to know what is the most frequently occurring group size is, so they can organize the seating arrangements to best meet demand. So he wants to know the most frequently occurring group size. So we have a sample of 20 selected at random, right? And these are the grouping that we have, or the sample that we have. We have 2, 4, 1, 2, 3. I mean, the groups, either 2 people or 4 or 1 or 2. So to put the best design, we have to know the most common one, right? So let's find the mode. Let me leave a space. Mode. Find the mode equals mode, single or multiple. We have 2. Also, we can use the multiple. We have 2 modes, which is 2 and 4. If you use single mode, we got 2. If you use multiple modes, we got 2 of them. So the 2 and 4 are the most common or the most occurring one. You can check this by sorting this out. Right-click sort. Look at the 2's. How many 2's do we have? And how many 4 do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We have 6 of the 2's, 6 of the 4's. So you have basically 2 modes. So the groups we have, so we're going to create tables of what? Maybe of 2 and 4's, right? The seating arrangements, they're going to be like table with 2 chairs or tables with 4 chairs. Maybe they're going to be the most common, appropriate, design, right? So the mode, we use it when we're actually talking about the most common things, when we look at the most common, and when we have a number of things. Usually the mean is the most common measure we use, but the mode is used from time to time, and it depends on the data. The other one, okay, so the second one we're going to do is the weighted mean. Let's take an example. So we have here a law firm was involved in a discrimination case, probably. So one ski instructor from Germany sued the operator of the ski resort, claiming he had not received equitable pay compared to others from Norway. So the mayor's attorneys plan to compute the mean annual income for all 7 Norwegian ski instructors at the resort. But because these instructors worked in different numbers of days during the ski season, the weighted mean needed to be computed. So yeah, because they have like different number of days. So the weighted mean, first of all, we're going to multiply, because this is the income. These are the number of days, 7,600 times number of days. So we're going to multiply income times the days, right? This is what we're going to do first. No, I want to keep it like that. Then this is equal in Excel. You put equal, you select the income, then you do shift number 8, which is times, then you select the days, then you click on or you put enter. After that, I'm going to click on the right corner when I see the plus sign and drag this. So we got all of these calculations have been done for you. So what did we do? We multiplied every income times number of days. If you can double click here, you can see that. You can now click either escape or enter. Escape, so you don't want to mess up with the calculations. Double click to check the calculations, escape button. Then what we have to find the total or the sum. How to find the sum of the days? The weights equal sum. I select all of the days, equals, same thing, the sum. Or actually you can pull that one, you can do both. You can say sum, select all of these. Now what we can do is finding the weighted mean. The weighted mean is what? Is basically, let me do that, is equal the income times the days, the sum of these guys, divided by the total number of days, the weights, equals. So the weighted mean is $5,668.52. So number of days work, if we take in account the number of days worked, the Norwegian ski instructors had a mean income of $5,668.52 if we consider the number of days worked. So this is the weighted mean. Next, we're going to do the percentiles. Percentiles, if I care about getting the percentiles, let me copy the question first. So the Henson Trucking Company is a small company in the business of moving people from one home to another within the Dallas, Texas area. Historically, the owners have charged the customers on an hourly basis, regardless of the distance of the move within the Dallas city limits. However, they are now considering adding a surcharge for moves over a certain distance. They have decided to base this charge on the 80th percentile. So they have sample of the travel distance data for 30 moves. These data are the follows, right? Okay. So we're going to find the 80th percentile. What does it mean? We are looking for the data. So let me just sort these. Just let me sort them. Okay, the sorting doesn't impact the calculations in Excel. Basically, we sort from large to the smallest, just in case. Yeah. So in Excel, we use formula. For the formula, there's no need to sort, but we need to see this, right? So we are looking for the 80th percentile value. What does it mean, the 80th percentile value? We need to look at the value within these values, that 80th percentile, that 80% of the data is located below this value, okay? So let's find the 80th percentile. So the 80th percentile, Let's find it. So to find this, we're going to use a formula in Excel called percentile. Equal, first of all, we have to write equal percentile. I'm going to use percentile.inc inclusive. Then I'm going to select the data. You have to select the data one by one, something like this, or you can use Command Shift down arrow together. Comma K. What is K? Is 80 percentile, 0.8. So it's 20.6. So the 80th percentile is a 20.6. So any distance exceeding 20.6 miles, these are in miles, any distance exceeding 20.6 miles will be subject to the surcharge. Where is it 20.6, by the way? 20.6 is somewhere here. Somewhere in the middle here, right? Between these two values. No, sorry, 20.6 here. So 20.6, so we have 80% of the data less than this value. Look at them, all of them. So anything exceed 20.6 miles will be subject to the surcharge. This is the percentile, the way we find the percentile, okay? The last one is doing the quartiles. This is another example. We have miles driven for a vehicle, and we're going to find the first quartile, second quartile, third quartile. First quartile equals quartile inclusive. Second one. I'm going to select the data. I'm going to select the first one, then I'm going to click on Command Shift down arrow together. Comma, what quartile are we going to find? First, second, third. I'm going to click on 1 because this is my first quartile. It's 249 equals quartile again. I'm going to select the data. Then I'm going to do comma, second quartile 2. This is my second quartile. And this is my third quartile. Select your data, click on the first one, Control Shift Alt, Control Shift down arrow, then comma, third quartile, then enter. We can graph these data using the box plot. So what I'm going to do, I'm going to select the data, go to Insert, Box and Whisker Plot. It looks weird, but let's try to fix it. Let's try to do right click. Let me take this to the other side. Let me choose the data set here, or the axes. The minimum is 0. I don't want the minimum to be 0. The minimum actually is about 200. Okay. And the maximum is not 400. I'm going to make it like 350, 360, 350. Okay. Actually, still the minimum is way away, so 220. Let's make it longer. Yes, this a little more readable. And if you look at the max and minimum and show outlier points, yes. Show inner points. Show mean marker, yes. Exclusive median or inclusive median is going to be a little bit different, but that's okay. It's kind of different way of calculating mean and median. And we can also change the fill, not the fill of this, basically. And you can play with the color, with border. Yeah, so you just do as we did before to make this readable. So this is box whisker plot, and first quartile is 249, which is somewhere here. This is the first quartile, 249. The second quartile is 259, is here. This is the line, 259. The third quartile, 266, which is here, that one, 266, right? And you can get the interquartile range. In this case, is 286. Sorry, this is the upper limit, this is the lower limit. These are the outliers. So to calculate the lower limit is Q. No, let me just copy it. It's a Q 1, which is in this case this guy, minus 1.5 times parentheses Q3 minus Q1 again, close the parentheses, enter. This is the lower limit. The upper limit is basically equals Q3, which is this one, plus 1.5 times, open parentheses, Q3 minus Q1. I'm selecting Q3 as Q1, okay? This is the upper limit, right? Any value exceeding these two values is less than the lower limit, greater than the upper limit is extreme values or outliers. Do we have outliers? Yes, we have this value, that value, because they're exceeding 291.5. So this is the quartiles and the box plot. Then you can give me the name here, miles driven, right? Yeah, this is everything for chapter 3.